Hey class, I wanted to go ahead and make you guys a short video for this workshop problem here. It seems a bit tricky with all the different things going on, lots of different information given here, but what I decided to do to tackle this is, as we have done so many other times, break it down into parts. I observed that we have the ball initially at this point 1 down here, where we're asked to determine with what velocity it needs to be launched in order to make it up this ramp, go off the ramp, and land here at point 3. And so I decided to break it down 1 to 2, where 2 is the point where it's just about to come off the kind of ramp edge there, and point 3 where it's just about to land. So in order to figure out the speed at point 1, I need to know how fast it has to be moving up here at point 2. And to figure out how fast it's moving at point 2, I have to look at how far it flies after leaving the top of the ramp. So I decided in looking at this that probably starting to evaluate from point 2 to point 3 is going to be important. And evaluating from point 2 to point 3, I'm going to immediately think about using kinematics, because I have something that's really undergoing projectile motion, an object moving solely through the air only under the influence of gravity. So I can observe at point 2, I have some v2 that I don't know, but I do know that that v2 is only in the x direction. v2 in the y direction is going to be 0 since it rolls off horizontally, which is helpful. My y height at point 2, if I redefine kind of this as my 0 for 2 to 3, kind of like this, then my y2 is going to just be equal to h2, make sure in meters though. My x2, probably I should write those backwards actually, let's undo this here. Keep my x and y's on the same spot here. So I would say x2 is 0 and y2 is just that height h2. x3, the location where it lands, is going to be the distance d, and y3 is going to be 0 because I'm again redefining this as my 0 height and this is my 0 in the x direction. And we know ax for something in projectile motion is 0, and ay is just going to be negative 9.8 or negative g. Now we don't know v3x or v3y, but that's okay, we don't need to. So from that, you should be able to use kinematics, starting with the y direction to find time. So I'm just going to write this over here, y direction, to find time. Then time to find v2x, which is just equal to v2. So I'm going to let you guys do the kinematics, but that's the process that hopefully you'll be able to go through to evaluate and find what v2 is equal to. Ooh, v2 equal to. Ha. Anyway, then you're going to want to evaluate from 1 to 2. So from 1 to 2, you're going to want to use the idea of, let's see, you got a ball rolling, going up a ramp, some vertical height. That immediately makes me think of conservation of energy. So E1 plus work non-conservative is going to be equal to E2. At point 1, what do we have? Well, we have a ball that's moving, so we have 1/2 mv squared, and I'll call that v1 so I know which v I'm looking at. But it's also rolling, since we're told this thing is rolling smoothly or rolling without slipping, so I'll also have 1/2 I omega 1 squared. Keeping in mind, right, that for a ball rolling without slipping, v of the center of mass is equal to omega times r, or omega is going to be equal to v over r, whether we're talking about point 1 or point 2. And that's it in terms of my initial energy. There's no work non-conservative by outside forces, so that has to be equal to my energy at point 2, which will also be a combination of kinetic energies, where I have 1/2 m v2 squared, and rotational, so 1/2 I omega 2 squared. And I'm also going to have mgh, where the h at point 2 is labeled as h1. So from there, you should be able to actually solve for v1 by making this substitution here and observing that I, for a solid sphere, is going to be 2/5 mr squared. So you plug those two things in together, and in this one simple equation, once you have v2, you should be able to solve for v1. So I'm going to leave that there and use that as a help video for you all. Hopefully you guys have a box-worthy night and are able to get a box-worthy answer in time for your class tomorrow. Have a great day.